Hello folks, I'm today going to use a little bit of software here. It's called Geometry Sketchpad. It's a handy little tool to take a look at parallel lines cut by transversals. We have a line here, and what we're going to do is create a line, some other lines here. We're going to look at a transversal, and then we're going to create another line that's parallel and see what happens. Now, we've been talking about all these angle relationships that are formed by transversals, right? The alternate interiors and the in consecutive interiors and all those wonderful things. But we want to look specifically today at what happens when the other line is parallel. Okay, so the first thing I'm going to do is I'm going to draw the transversal. This might be a little bit out of order, but I'm going to do it this way anyway. All right, so this pink line is going to be my transversal. Let me write transversal here. Pink line is the transversal, and we can grab this transversal and we're going to be able to move it around anywhere we want, and that's going to be key to our little study here. All right, so what I want you to notice is that anytime two lines cross, transversal or otherwise, we get some angles in the picture, right? So for example, to the left of the transversal, I have this angle here that goes from here to here to here, and I can ask Geometry Sketchpad to measure that angle for me. Well, I thought I could anyway. If I can stop screwing up. Click, click, click. There we go. All right, Geometry Sketchpad. All right, so Geometry Sketchpad says that angle right there, Miss Britton, is 49.37. And that makes sense. It's a little acute angle right there. Now, what I want you to see here is that if I move my transversal and I scooch it down here to make it even smaller, Geometry Sketchpad keeps telling me the measure of that angle. Right? I can make it so tiny and it just keeps telling me, look how little that angle's getting. Or I can move my transversal way over here and turn this into a really big angle, and Geometry Sketchpad keeps its measurement. Okay, so we're going to use this strategy here to check out what happens with angles when there's another parallel line. So the next thing we got to do is actually create a parallel line. And again, this is pretty cool. Watch this. So I can make a point and pop it up here, and then I'm going to say, hey, Geometry Sketchpad, do me a favor. Make a line that's parallel. It's going to go through that point, and it's going to be parallel. Here it comes. Okay, I'm going to make that line green as well, so my parallel lines match. Okay, so you see here, these lines are perfectly parallel. I didn't just draw them parallel. I asked computer software to make them parallel, so I know they're parallel. I'm going to put a little point here where they intersect to help me out. So watch what I'm going to do here. I'm going to go up to this new little cluster of angles that I made, and I'm going to ask it to measure the same angle that I did down here. I'm going to ask it to measure the corresponding angle up here. So I'm going to go right, the same angle. And you will be shocked to see that it's exactly the same. Because all I did was basically make a copy of this cluster of angles. I made a copy of it straight up to here. This angle is exactly parallel to this angle. So if the transversal cuts through this one at a 46-degree angle, when it gets down here, it's going to be a 46-degree angle. And I want you to notice that when I move my transversal, they move together. They get bigger and smaller together. Exactly. Okay, let's see if it works with the other ones. So if I come up here and I measure this big angle, right? So we know that when this transversal comes down and cuts this line, it's going to create two angles, an acute angle on one side, and this is going to be an obtuse angle. And there it is. It's 132.06. And in fact, in case you were wondering, let me see here. We can ask Geometry Sketchpad to add these two angles up for us. Watch, we're going to say, take this angle, and take this angle, add them up. And look what it tells us. something else we already knew. That if you have these two angles right next to each other, they're going to equal 180 degrees. And watch, when I move my transversal, watch these angles. They change sizes. But watch here up in the upper right-hand corner what doesn't change. No matter how I move this transversal, you see those angles measures are changing. What never changes is that number up there. That when you add those two angles together, they're going to add up to 180 every single time. Okay. So again, I should be able to come down here to this corresponding angle, and I'm guessing we're going to see the same thing. I'm not guessing. I actually know, but it's just fun. The suspense. There we go. Angle GFC, this angle right here. Look, it's exactly the same. And again, I can take this transversal and move it. Those two smaller angles on the left stay identical. These two bigger angles on the right stay the same. They're moving, they're changing, but they're always the same. Okay. So this is really important because it's really important that you see that we've got these clusters of angles, right? So I'm going to make these ones up here blue, and I'm going to make these ones down here, I don't know, how about red? Okay, so up here I've got a blue cluster of angles, and down here I have a red cluster of angles. Well, look what we know. We already found out that corresponding angles are congruent. Okay. So if I know this angle, I immediately know this angle. They're congruent. And over here I have a pair of corresponding angles. Now, literally all I need is this one angle though, because check this out. I know these are vertical, so I don't even need to ask Geometer Sketchpad to measure this for me, but I'm going to anyway. I know that this angle down here is vertical to EGH, so I know in my geometry soul that they're going to be the same, but let's have it measured anyway. Sure enough, look at that. These two vertical angles right here are sure enough congruent. So again, when I move around, notice these two, those two that are vertical to one another, stay the same. And that's important because now I know that this one down here has that same measure. And again, I don't have to ask Geometer Sketchpad for this, but why wouldn't I? How about that? Same size, but we knew that already. Now, why am I beating this dead horse? I'm driving this point home because look what I just created now. If I take this blue angle up here and this red angle down here, I just created a pair of alternate exterior angles. That is the second kind of angles we talked about. So I know that my corresponding angles were congruent, and now I'm finding out, look at this. My alternate exterior angles are congruent too. Let's see if it's going to work over here. So if I do this all again, if I say boom, 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 give me this angle in the bottom left-hand corner. Measure that. Look, not surprisingly, it matches this corner up here. Because again, these two have to make a straight line together. So if these two make a straight line together, then these two are going to be the same. Okay, so I've got two pairs of alternate exterior angles that are congruent. Now, let's look. What's going on with our alternate interior angles? I've got this blue one up here, IGF. If I go to the other side, stay interior, and go to the opposite side, alternate interior, so I'm making my X. Look, 46.96, 46.96. They're exactly the same. And again, we don't even have to ask, but let's do it anyway, just for fun. Let's get this measurement of this angle right in here. So H, G, F. look at this. It's the same as this one down here. Alternate interior. They're congruent. So now I'm starting to think, geez, is like every single pair of these special angles going to be congruent? Look at this. Corresponding angles. Congruent. All the pairs of corresponding angles are congruent, which isn't surprising because I literally just took this cluster and made a copy down here, right? My alternate exterior angles are congruent. This one and this one, and then EGI up here and DFJ down here. Congruent. My alternate interiors are congruent. I can come in here and make an X. I have congruent angles. So the last relationship we have is our friends, the consecutive interiors. And what's their point? To come along and not be congruent. They're the only relationship here that isn't congruent. But no worries, because look what they are. They're just like these two up here. If I take these two angles and I add them up, they're going to be supplementary. They're going to add to 180. So let's do that. Let's take this one and this one. And again, look what happens. 180, exactly. And I'm going to go move my transversal, and it's not going to matter. Watch. Changing the sizes of those angles. So this one's only 43 now, and this one's 136, but they're still adding up. They're always going to add up to 180, no matter how you change these angles, no matter how you move this transversal to change those angles. The alternate exteriors, the alternate interiors, and the correspondings are all going to be the same every time. The only ones that won't be the same are the consecutive interiors, because this is a little one and this is a big one, but they're going to add up to 180. So the thing is, if you have parallel lines being cut by a transversal, if someone gives you one, you've got them all. I like to call it a little zigzag. So if you start in this upper hand corner, you jump across, that one's the same. Then you jump across the transversal, that one's the same. And then you jump through here. Right? So if this is 47, no, 47, 47, 47. If you know this is 47, you can figure out this one because you know they add to 180, and then you do the same thing. Zig, zag through. It's very convenient. Okay. Now, I want to point something very important out to you. This magic only happens if the lines are parallel. So watch what's going to happen when I come down here. And I'm going to draw a line that is decidedly not parallel. In fact, I'm going to make it a different color. That's a bad color to pick. I already used blue. Purple it is. Okay, this line is not parallel to this green line. You can see that. I'm going to make it even less parallel if that's a thing. It's not even a thing, but I'm going to do it anyway. That is those two lines. These green lines are parallel to each other. This purple line, not parallel. Not even close. But watch the magic not happen. If I come in here and I say, okay, measure this angle, geometer sketchpad, if you would. This one right here. This one right in here that goes from F to J to this point out here. It's not the same. So up here, 133.5. Jump down here in corresponding angle, 133.5. But when I jump down to this corresponding angle, it's not the same. They're only going to be the same if the lines are parallel, because it's only when the lines are parallel that you're literally just making a copy for a 4-angle cluster, literally doing like a copy paste, boom, down here and making another identical cluster. If the line isn't parallel, if it's angled a different way, that magic isn't going to happen. So please, when you're using these relationships, it's not that those relationships don't exist. We could still call this angle right here and this angle right here corresponding angles. They're still corresponding. They still have that same top right position in their cluster. But because these lines aren't parallel, we can't assume they are congruent. Now, if this line was parallel, let's see if I can. You think I can get close? Yeah. Oh, so close. So look, this is 133.5. I made it so this is 133.55. Look at the lines. When they're parallel, these angles are going to be the same. As soon as you knock them off kilter and they're not parallel anymore, you lose that magic. This is an incredibly important idea in geometry, and it comes up a lot when you go to later classes, like when you do Algebra 2, when you do pre-calculus. Parallel lines cut by transversal comes up so much, and you always have to know that those angle relationships, they're almost all equal except for that one stinker, the consecutive interiors. All right, but you can figure out from one what all of them are. All right, so I hope this little Geometer Sketchpad animation helped you, and we will see you soon.